Hey guys, I thought I would make a video going over the even problems on this assignment and then answering questions over the odds if you have them, okay? So, just going to open up a few more of my pens and get going. Alright, so number 2, it says cosine is square root of 3 over 3, and where theta is between 3 pi over 2 and 2 pi, which puts us in the fourth quadrant. So if you think about this, 3 pi over 2 is right here, and 2 pi is right here. So we're in somewhere in this quadrant. So I'm going to create a triangle in the fourth quadrant. And, okay, I'm thinking that, well, there's two different ways to work this. You can either know where square root of 3 over 3 is coming from. Square root of 3 over 3 is the rationalized form of 1 over the square root of 3. And this would be an easier way to deal with this. If you notice that, then you could say if cosine is 1 over the square root of 3, then adjacent is 1 and opposite is the square root of 3. If you don't notice that, then you just go ahead and say adjacent is square root of 3 and hypotenuse is 3. I don't know if I said hypotenuse a second ago. Adjacent would be 1, hypotenuse would be square root of 3, so adjacent over hypotenuse. But if you don't notice that, then just use this, and there we go. Okay, so I want to go ahead and figure out this side using Pythagorean theorem. So I'm going to say the square root of 3 squared plus b squared equals 3 squared. Side squared plus side squared equals hypotenuse squared. So I've got 3 plus b squared equals 9. That means b squared equals 6. So b equals the square root of 6. Now, if you had done it, I'm going to go ahead and use this space over here. If you had done cosine of theta equals 1 over the square root of 3, then you could have said adjacent is 1, hypotenuse is the square root of 3. And then this would have been 1 squared plus b squared equals the square root of 3 squared. So 1 plus b squared equals 3. And then b squared equals 2. So b equals the square root of 2. So this, you'd have square root of 2. This one, we're going to have square root of 3. What's going to happen is if we do it this way, then we're going to have to do some simplification later, and that's okay. So one thing to keep in mind is location. The fact that we're in this quadrant means that this is going to be a negative side length, okay? Well, not negative side length, but location-wise, the opposite of that angle is negative. Okay. The question is, what is sine of 2 theta? So keeping in mind my identities, I know that sine of 2x, just a reminder, is 2 times sine times cosine of the same angle. So sine of 2 theta is equivalent, oh, yeah, I labeled it, is equivalent to 2 sine of theta cosine theta. And so in this case, I've got sine of theta. Sine is opposite over hypotenuse, so negative square root of 6 over 3, times cosine of theta, which is square root of 3 over 3. So if I multiply straight across, then I see that I have negative 2 square roots of 6 times 3 is 18, divided by 3 times 3, which is 9. But the square root of 18 is not fully simplified, so 18 is 9 times 2, so I would say negative 2 times 3 square roots of 2 over 9, but the 3 and the 9 simplify. So it would be negative 2 root 2 over 3, and that would be my final answer. Okay? If I had done it with this one over here, 2 times sine, sine is opposite over hypotenuse, so it would have been, opposite over hypotenuse. So square root of 2 over square root of 3, and then times cosine, which is adjacent over hypotenuse. So 1 over the square root of 3, and I would have gotten, oop, that's a negative. So I would have gotten negative 2 root 2 over the square root of 3 times square root of 3, which is just 3. So it's however you see it. If you don't recognize that as the rationalized form of 1 over the square root of 3, then you can just use it and the numbers will still work out, okay? Number 4. Also, I don't know if you can notice, but I did get a slightly newer document camera. I don't know if it's something you can tell, but no, we'll see. Okay, again, we are in the fourth quadrant, 3 pi over 2 to 2 pi. So I'm going to go ahead and draw the fourth quadrant, draw a triangle. Now let's talk about this, negative 3 root 7 over 7. Okay, In this one, I'm going to kind of insist that we go ahead and start recognizing, if we can, this right here is the rationalized form. I'll guess I'll work it out without unrationalizing, but it would be so much easier if instead of using this, negative 3 root 7 over 7 is just the rationalized form of negative 3 over the square root of 7, and that's just going to be so much easier. But since some of you probably didn't do that, I'll go ahead and think it out. Now, notice how I put the negative up top. The negative technically could be either with this or with this. Fact of the matter is that tangent is sine over cosine, y over x, and in this case the y is the part that's going to be negative. But if we'd been in the second quadrant, then we would have had to put the negative with the x, not the y. Okay, so I'll work it out this way, but it would be so much easier if you recognized it as this. So opposite, negative 3 root 7, and adjacent 7. So we need to find the hypotenuse. So we've got a squared plus b squared equals c squared. So that's 49 plus negative 3 squared is 9 times 7 equals c squared. So I've got 7 times 7 plus 9 times 7, that's 16 times 7. I don't know if that makes sense to you. 7 sevens plus 9 sevens is 16 sevens. So yes, that is 70 plus 42, so 112. Yeah? I should probably make sure on that. 49 plus 63, yeah, 112. Which you would then have to break down into the perfect square, simplified. But if you do it this way, if you notice when you can do something like that, this is something times 7 and this is something times 7, so just add them. 7 sevens plus 9 sevens, 16 sevens, which makes it really easy. Oop, just kidding. Because then c equals 4 root 7. So the hypotenuse is 4 root 7. Okay? Alright, now we need to find tangent of 2 theta. So I'm going to go to my identities page and remind myself that tangent of 2x is 2 tangent divided by 1 minus tangent squared. So I'm going to write that down real quick. 2 tangent divided by 1 minus tangent squared. Okay. So I need to, actually, wow, that's actually kind of sad. In order to do this, I didn't really need to find the hypotenuse because the formula for tangent of 2 theta requires no sines or cosines. It just requires tangent. And I already have tangent. So, perfect. 2 times tangent, which is negative 3 root 7 over 7, divided by 1 minus tangent squared, so negative 3 root 7 over 7 squared. I'm going to go ahead and over here write it as if I'm using tangent equals negative 3 over the square root of 7. 2 times negative 3 over the square root of 7 divided by 1 minus negative 3 over the square root of 7 squared, and we'll see as far as simplifying goes what happens. So for this one, in my numerator I get negative 6 root 7 over 7. And in my denominator, I get, well, this right here is going to be negative 3 squared is 9, square root of 7 squared is 7, and 7 squared is 49. The 7 and the 49 can simplify to just a 7 in the denominator. So all of this squared is just 9 sevenths. So I'm just going to put 1 minus 9 sevenths. The negative goes away because a negative times a negative is positive. This negative, not that one. Now, 1 minus 9 sevenths, remember common denominator, we can rewrite 1 as 1 over 1, and then multiply top and bottom by 7. So 7 sevenths minus 9 sevenths is negative 2 sevenths. So negative 6 square root of 7 over 7 divided by negative 2 sevenths. And then we're going to multiply by the reciprocal, negative 7 halves. Then we can simplify. A negative times a negative is a positive. The 7's can cancel out. They can simplify out 7 divided by 7. And 6 divided by 2 is 3. So my final answer is 3 root 7. And there we go. Okay. I'm going to go ahead and simplify this expression if you had done it that way. So I've got negative 6 over the square root of 7 over, let's see, yeah, pen is dying, over 1 minus, now negative 3 squared is 9, and square root of 7 squared is 7. So you can see how we get the same thing in the denominator, 1 minus 9 sevenths, which we know is negative 2 sevenths. And then my numerator, if I rationalize that, go ahead and rationalize it, then I get the same thing I had in my numerator. So it's up to you. That's however you want to work it, but there is less simplification that needs to occur over here. Slightly. Okay, it's whatever you see. Alright, the rest of the problems are verifying identities. So these can be kind of tricky because it's not so much simplify as much as possible until you get this very simple expression. It's more like manipulate it until you can get to the other side. So I'm probably going to be working these sides from, or these problems from both sides, so that depending on which side you picked, we can talk about it, okay? Plus I've got some, like, you know, tricks of like how to do this, or how to, like, what things to think about that make it easier. So I'm going to go ahead and I'm going to start from this side first, but I'm going to keep in mind what I want, okay? So when I think about this side, I'm going to write 2 times cosecant is 1 over sine. So I'm just going to write this as this is sine, in the numerator this is cosine, and then cosecant is a sine in the denominator, right? Well, in fact, we're there, because this right here, you have to remember, if your goal is sine of 2x, then you need to keep in mind what sine of 2x is. Sine of 2x is 2 sine cosine. So, in fact, I'm done. And if you wouldn't mind, guys, start putting this out to the side, like which direction you're going. You're going left to right, or you're going right to left. So that'll help me figure that out. Okay, now let's go right to left. Okay? Or if you want, you can say right to left. Well, whatever. Okay, so I'm going to start with sine of 2x over sine. The first thing I'm going to do is I'm going to replace the double angle. So 2 sine cosine divided by sine. Now, absolutely, we could simplify out these cosines, but I have to keep in mind what I want as my answer. I want a 2, I've got a 2. I want a sine, I've got a sine. I want a cosine, I've got a cosine. So I've taken care of all of these things, right? I want a cosecant, well, guess what? I have a sine in the denominator. So if I have a sine in the denominator, then all I have to do is bring it up, and I've got a cosecant. So 2 sine cosine times cosecant. And yes, the order is not the same, but I don't really care because it doesn't matter. Multiplication is commutative, so we are done. And there you go. All right, let's look at number 8. On number 8, if I work, let's see, left to right. I need to get this somehow to cosine squared minus cosine of 2x. Okay. So I'm going to keep in mind what cosine of 2x equals. Cosine of 2x equals all of these things. So I'm going to write all 3 of those things down on here so that I can have them for reference. So this right here is cosine squared minus sine squared. It is 1 minus 2 sine squared. And it is 2 cosine squared minus 1. Now, to make my life a little bit easier, I'm going to go ahead and apply the negative. So if I think, okay, I need negative cosine 2x, then this would be minus and this would be plus. This would be minus and this would be plus. This would be minus and that would be plus. Okay? So if I get any of these expressions, then I can replace them with cosine 2x. But we'll have to see what happens, okay? So I'm going to go ahead and replace all of this in terms of sines and cosines. I am going to bring the secant up as, the secant squared up as cosine squared. So when I have tangent squared, I have sine squared divided by cosine squared. And then secant squared can be brought up as just cosine squared in the numerator. Yeah? So I broke the tangent squared into sine squared on the top, moved my cosine squared to the bottom, but then the secant squared right here I moved up as cosine squared. And that doesn't look like any of those. But here's what I do see. If I simplify out the cosine squares, then I just have sine squared. True? Okay. Well, if you look at this side right here, I've got cosine squared minus cosine 2x. Well, if I take cosine squared and I subtract cosine squared and I add sine squared, those two go away and I'm just left with sine squared. So what I'm going to do is I'm going to do some trickery. I'm going to add cosine squared and subtract cosine squared. I can do that because I'm adding and subtracting the same thing, which means technically I'm just adding 0. Cool? So, if I manipulate this, I need a cosine squared, so I'm going to do that. Cosine squared. And then I need minus cosine 2x. So I'm going to go ahead and write plus sine squared minus cosine squared. But I know that the identity is for cosine 2x, or for negative cosine 2x, is negative cosine squared plus sine squared. So I think what I'm going to do is just reorder this cosine squared minus cosine squared plus sine squared. And then this right here is a negative cosine of 2x. And there we go. So it's keeping in mind what my identities are. I manipulated my cosine 2x by taking all of these and then changing the sign, so I made a negative, positive, negative, positive, negative, positive. But the only way that I could do this is by thinking about both sides at one time, okay? Because it's not just going to pop out at you what I can do from here to get to there, unless you also think about what's happening to this side, okay? So I'm going to work the problem again, but from the other side. So tan squared over secant squared equals cosine squared minus cosine of 2x. So I do have some options as far as cosine of 2x goes. So if I were going to do right to left, then I'm going to start with cosine squared, and cosine 2x, I'm going to go ahead and use the first one, cosine squared minus sine squared. I'm going to distribute my minus sign, and I'm going to see that I get cosine squared minus cosine squared plus sine squared, and then that just gives me sine squared. So then you're sitting here like, okay, well I've got sine squared, but I need tangent squared divided by secant squared. So here's what I know. In order to have tangent, I must be dividing, I have sine squared over cosine squared. And secant squared is the same thing as multiplying by cosine squared. So if I need to both divide and multiply by cosine squared, which I can do because that means I'm multiplying by 1, then I can see that this right here is tangent squared. And then multiplying by cosine squared is the same thing as dividing by secant squared. And there we go. Okay. Number 10. So I've got sine squared over sine 2x times tan squared, and I need to get to all this crap over here. All right. I'm going to go ahead and rewrite, well, first I'm going to do two things if I go left to right. I'm going to leave the numerator sine squared. Well, yeah. Then I'm going to replace sine 2x with 2 sine cosine. And then I've got tangent squared, so what I'm going to do is I'm going to bring that up as cotangent squared. And then I think I'm going to split those up, okay? So sine squared is sine times sine. Cotangent squared is cosine. Cotangent is cosine over sine, yeah? So cotangent squared is cosine over sine and cosine over sine. So let me just go ahead and do that. Cosine over sine, cosine over sine. This is all just multiplication, division. It can all just, numerator, denominator. And then let me just put this back in the denominator. 2 sine, cosine. okay? So in splitting all of this up, I've got sine squared, so I've got sine times sine. I've got tangent squared in the denominator, that means cotangent squared in the numerator, which is cosine over sine times cosine over sine. And I've got sine 2x in the denominator, which is 2 sine cosine. Now I'm going to take this, and I'm going to look at what I need. I need a tangent, which is a sine over a cosine. So I'm going to take this right here. I'm going to rewrite that as tangent in the numerator. I need a cosine squared, which I have right here. So I'm going to write a cosine squared. I need a 2, got it. And I need a sine squared. So if I do this right here, then I've got a sine squared in the denominator. And which means I don't need those, and that's good because they simplify each other out, and so I'm done. So by just splitting it all up and going from there, I can see where I get to my answer. All right, now I'm going to work right to left. So right to left. Okay, like I did before, I'm going to go ahead and rewrite in terms of sines and cosines. So my tangent is a sine and then a cosine in the denominator. My cosine, I'm going to go ahead and split up as cosine times cosine. And then my denominator is 2 sine squared, so sine times sine. And you can see that we're in the same space, or the same spot that, well, kind of we were, but we need this right here, right? So I'm gonna identify what I have and go from there. Okay, I need a sine squared in the numerator. I don't have one. Okay. I need a sine 2x in the denominator. I do have that. 2 times sine times cosine. So I've got a sine 2x. And I need a tangent squared in the denominator. Well, I know that a cosine over sine is cotangent, right? So I'm going to go ahead and block this off. That's going to be a cotangent in the numerator. I'm going to go ahead and write that. And I've got another cosine. I need another cosine over sine, and I need another sine in the numerator. I need a sine squared on the top, right? Which means if I just multiply top and bottom by sine, yeah? Then this right here, my sine times my sine, is my sine squared that I needed. Okay, so I've got sine squared, I've got sine 2x, and my other cosine divided by sine, that's another cotangent in the numerator, which is just cotangent squared, and cotangent squared in the numerator is the same thing as tangent squared in the denominator. And there you go. Okay, so those are kind of tricky. I have not worked out the odds, but I would be happy to if you need some help whenever you are working them, or if you need some help at this point. Tomorrow I'll post a video going over the evens or the odds on the 5.3 day 2. If you have any preferences on which ones I work, if you would rather I work one versus the other, then just message me on Remind or email me. Okay, I look forward to hearing from you.